For this question, show that the expression can be written in partial fraction. First, we look at our fraction here. Numerator is a power 4 function, and denominator, as we expand this, we will get x squared. X squared times x will be maximum power will be x power of 3. So when x power of 4 divided by x power of 3, this is improper fraction. So for improper fraction, we have to simplify first by using long division. So first, we find out what is our divisor here. Expand it. As this expand, we'll get a squared plus 2ab plus b squared. So expand some more. Multiply it to the x. Again, multiply it to 1. Then we're going to start to do our long division. For the term of x power 3, we'll put 0. For the term x power 1, also we put 0. So our first coefficient here, perkali here, is 1 times x. So time expand in will become 4x4. Then expand to the x squared here. X cubed. Expand to the 3x here. Then we finding the remainder. Remainder is equals to 8x cubed. Here minus become positive. So minus 9. Then bring down the constant 1. Then we repeat again. So to get the coefficient 8, we need to times 2. So here we need a 2 here. Then we multiply up here. We get 8. Continue. Then we finding the remainder, we minus up. So 5 minus 6, negative 16, positive 21. From here, we rewrite our answer. When this long division finish, we have a quotient here, which is x plus 2. Then plus, remainder here is 21x squared minus 13 minus 3x over 19 over the divisor. So the divisor we can put in factorized form. So step number 2, we're going to observe our divisor here. So the divisor here is completely factorized. Therefore, we can split according to our factor here. So from here, as we can see, we have 1 linear factor and one repeating factor. So for repeating factor, to express in partial fraction, the first time we use 2x plus 3, then we repeat it, 2x plus 3 square. Then one is linear factor, so just split it as x plus 1. As we can see, when we have linear here, means numerator here, it will be a constant. So for here it is repeating factor, so inside here actually is linear, so up here will be a constant. So for this also a linear factor, up here will be a constant c. So we managed to show this. Then for question B, they say from part A, determine this value A, B, C. So hence we have to integrate the fraction here. So by referring to this equation, our remainder part here will be expressed in partial fraction. So this is the part that we're going to split up into the partial fraction according to the factor pattern here. Then we form an equation where we can equal the denominator. So for numerator, we will look at our constant here. We'll multiply to the factor that you don't have. So you can see completely denominator having two factor of 2x minus 3 and x plus 1. So for here, A will be going to multiply one more factor, 2x plus 3, another factor that you don't have, x plus 1. Meanwhile for B, so you can refer here, denominator already having 2x minus 3 square, so the factor you don't have, you have to multiply out as 1, so that it can equal back to the complete numerator here. So for C, you are going to multiply with 2x plus 3 square. So after we getting this equation, we can find out our ABC by using let method. So we can let x equals to negative 1, one of our roots. So when we substitute here, we can get 5. So when we substitute here is 0, 0. So we have 25c. So automatic c is 1 over 5. Then we can repeat again, let another value. We can find out from our roots where this 2x plus 3 can give us a root of negative 3 over 2. So when we substitute negative 3 over 2, put in here using your calculator. So when we substitute here will become 0. Here we will get negative 1 over 2b. So I have a mistake here in writing. It will be minus. So the roots here will be 3 over 2. Five over 2b. So B we simplify. Then we continue for finding A. We can let it to be any value. For easier to calculate, I let it to be 0. So calculate for this. Where B, we already found it. And also C, we already found it. So solve our A. So then finally express back our answer. Substitute back our ABC. A 101 over 10. B 19 over 2. C 1 over 5. So the next part we're going to finding the integration for this fraction. So it will be equivalent to integrate our result of long division where our ABC already found. So it will be equal to integrate x plus 2 plus these partial fractions. So to integrate x, we get x squared over 2. To integrate 2, we get 2x. So for this 101 over 10, we factorize out. Integrate 1 over fraction, so it will be ln. Divide by the coefficient of this ln, which is 2. Plus, so to integrate this, it will be equivalent to 19 over 2. For the whole bracket, we can put up because it is power of 2. We write it into the power of negative 2. So this is no longer fraction form. This is fraction form. This is fraction form. When our denominator power 1, we will not take it up to be power negative 1. So for this part, the integration will be 19 over 2. So the bracket plus 1 over new power, coefficient is 2. And then back to this 1 over 5. Integrate 1 over x plus 1. So this will be give you ln. Coefficient of x, 1 plus c. Then we simplify this. So this will be negative 19 over 4. Then rewrite the power of negative back to the denominator. For the first part, how do we get these 3 marks? So the first part is concept of long division. Then write our answer and then prove it can be expressed in partial fraction form. Then after that, to express in partial fraction, so since this is given, so this is the concept for us to find out the equation. And then we have 3 let here to find out 3 unknown A, B, C. So 2 marks for our answer. Finally, we answer the question of integration. So express our integration in the form of partial fractions. And then for the first part, so this is the concept of integrate using formula 1, 2. Meanwhile, for this is another concept of integrate, which is integrate to get ln. And then here is another concept of integrate, a bracket of x, formula number 3. So finally, we're going to see the integration answer. This answer. So finally, everything correctly, we get you another mark, simplify the answer.